Friends, right now we'll be looking at the different periodic trends in properties of the elements of the periodic table. The first property that we'll be looking at will be something which is called as the atomic radius of all the atoms which are present in the periodic table. We will be looking at the trends, that is, if in case we go from left to right of the periodic table, what is going to happen to the radius of the various atoms of different elements. If in case we go from up to down in the periodic table, what will be the effect on the atomic radius of the various elements which are present in one particular group. Let us now, before we go into that, understand what is the meaning of the atomic radius or the atomic size. When we talk about atomic size, we basically talk about what will be the size of that, whether it will be a small size, whether it will be large size. How do we understand? How do we calculate atomic size? Atomic size basically means the size of the atom. The size of the atom basically can be either calculated by the atomic diameter, by the diameter of the atom, or by the radius of the atom. We normally use the term radius for understanding the atomic size. So from now onwards, we will be, whenever we are talking about atomic size, we are indirectly talking about the atomic radius. So that's one thing which you need to realize right now before we proceed ahead. Now, even after we consider atomic radius, which is nothing but the length, the distance between the center of an atom to the center of the atom, in the sense like the center of the atom, which is nothing but the center of the nucleus, or simply the nucleus, because the size of the nucleus is extremely small as compared to the size of an atom. So therefore we have atomic radius is nothing but theoretically defined as the distance between the center of the nucleus of an atom to the outermost shell of that atom. Now see, theoretically speaking, it is very simple, right? It is very simple to calculate the center of the atom and then the outermost shell and then find out the difference between the distance between them. But in reality, it's not so, because as we have seen in Heisenberg's uncertainty principle and the meaning of the term of orbitals, electrons, they do not exactly move in a circular or even elliptical orbit around the nucleus of an atom. The electrons, they can be at any position at any point of time around the nucleus of an atom. There is only a specific region, three-dimensional region around the nucleus, wherein the probability of finding an electron is the highest. Therefore, an electron can be present anywhere around the atom, anywhere around the nucleus in an atom. However, there is a concept which is called as an electron cloud concept, which means that an electron, it is not present. Each electron is not present at a fixed distance from a fixed radius from the center of the atom. However, that electron, because it is free to move, it is moving at the speed of light. That is the reason why if in case you look at it at an atom from an ultra microscope, you will actually see a kind of cloudy region around the nucleus of an atom, and that cloudy region is not exactly spherical in shape. At some place it might bulge out a little, at some places it might come inside a little bit. So therefore we need to take average of such radiuses if in case we want to find out the radius of an atom. So what I'm trying to tell you, my dear friends, is that it's when we're talking about the atomic radius, it conceptually, theoretically, it might look simple, but in reality, it is very difficult to find out the actual radius. However, we will be showing right now how to find out the covalent radius in the case of non-metallic compounds. Like if in case we consider chlorine, then in the case of chlorine, what will be the covalent radius be like? Let us see. So in the case of chlorine, if in case we consider the nucleus of chlorine, so the nucleus of chlorine, if in case we represent it with the help of this dot, and this is the nucleus of another chlorine atom. First of all, you guys need to understand that here we have a covalent bond which will be forming between two chlorine atoms, wherein one electron will be given by one chlorine atom and one electron will be given by another chlorine atom. So we consider the covalent radius when we are trying to find out the atomic radius of the non-metallic substances, including like hydrogen. So in the case of chlorine, if in case we see, we will be having a centrally placed nucleus, and then we will be having a cloud of electrons of the two atoms. So if in case we look at the cloud of electrons, it will be something like this. And we know that whenever like two atoms they come closer to each other, the distance between the nucleus of the two atom it decreases. So therefore here also we will be having a slight decrease in the distance between the nucleus of the two atoms. So even here we will be having chlorine atoms, which will be two chlorine atoms which will be coming closer to each other. So here we will be also be having the different atoms of chlorine which will be coming closer. So therefore we will be having this situation wherein we will be having the electron density which is shown here with the help of electron cloud. So this, the one which I have shown in white, this is nothing but the electron cloud of the two chlorine atoms. Because both the atoms are belonging to the same element, that is the reason why the electron cloud will be exactly the same in both the situations. As we can see, the distance between the nucleus of the two atoms can be shown here in yellow color as I am showing. Now this is the distance between the nucleus of the two atoms. Obviously there will be, the two nucleus will be present at an equilibrium distance wherein the attractive force is at its maximum and the repulsive force will be at its minimum, as you have already learned in chemical bonding chapter, right? So therefore here what we will be doing is that we will be considering the distance between the two nucleuses, because the two nucleuses can be very easily be seen through an ultra microscope, because they are extremely dark spots which are present, and around it there will be electron clouds. So if in case we consider the distance between the two nucleuses, and if in case we consider the distance between the two nucleuses as equal to d, we know that d will be equal to 2 into r, and therefore by dividing d equal by 2, if in case we know that d is equal to 2 times into r, if in case we divide the value of d by 2, we will be getting the value of radius of each atom which is present, and that can be considered as equal to the atomic radius. So therefore this is how we find out the covalent radius in the case of non-metallic compounds. In the case of metallic compounds, we find out the radius in another way, which is called as metallic radius. Why, sir? Because in the case of metals, the metallic atoms, they do not form such type of covalent compounds, because metals, they form metallic bonds which are present in metals. So therefore in metals we've got metallic bonds which are present, and hence in the case of metals we will be having something which is called as a metallic radius, which we will be taking care of. So let us look at what will be metallic radius. Again, when we have different metals which are present, different metal ions which are present in the metal crystal, then we will be again be finding out the distance between two adjacent metallic ions which are placed nearby, and with that we can find out the metallic radius. In a similar way, we can find out the metallic radius of a metal atom or metal ion. So in a metal crystal there will be two metal atoms which will not be bonded to each other, but which will be present very close to each other, which will be touching each other, and we consider such type of metal atoms or metal ions to find out the metallic radius. Finally, van der Waals radius. So see, my dear friends, we have here three different types of elements in the periodic table, right? Either we'll be having metals which are present, or we have non-metals which are present. Third type of category of elements that we have that is present is nothing but noble gases. Now, because noble gases do not form metallic bonds, nor do they form non-metallic type of covalent bonds, hence it is very difficult to find out covalent radius as well as metallic radius in the case of noble gases. Therefore, in the case of noble gases, we use a new term which is called as van der Waals radius. Van der Waals radius will be a situation wherein there will be a van der Waals force of attraction between two atoms, due to which the two atoms come very close to each other, and then we again calculate the radius in a similar way, wherein we take the total distance within the nucleus of the two atoms, within which there will be van der Waals force of attraction, and then we divide it by 2. So hence with that we get the value of the van der Waals radius of such type of noble elements. So this is how we find out the radiuses or the atomic size of different elements. So in the next video, my dear friends, we will be looking at the exact trend in the properties, or that is exactly what happens in terms of atomic size if in case we go left to right or up to down in a periodic table, looking at the different types of atoms.